Okay, this is an extension of section 8.3. I threw out a couple of the examples on the last video that you probably needed to finish your homework, so I'm going to go ahead and show you those and then allow you time in class to finish your homework. So example 7 is when we're looking at similar figures and we're trying to figure out specific values for x and y. So all you have to do on these is set up proportions, and I'll show you how. First, it says find the scale factor of polygon RSTUV. So since it listed RSTUV first, that's what is going to go on the numerator. So we're going to, when we make our scale factor, we're going to go big to small, since it's RSTUV 2 ABCDE. So that means I'm going to pick a side length, and the only one that I see is ST, where it also has the corresponding side length on the smaller polygon. So I'm going to take 18 over its corresponding side, 4, and reduce that to find my scale factor. So 18 and 4 are both divisible by 2, so 18 divided by 2 is 9, 4 divided by 2 is 2. So my scale factor is 9 over 2. Or you could also put this as a decimal and say 4.5. So that means the smaller polygon, RSTUV, is 4.5 times larger than the smaller one. Now let's use proportions to solve for x and y. We already found the scale factor, so we know how these two are different scales. So to find x, I'm just going to take my side length for x and write it as a ratio to its corresponding side on the smaller polygon, which is 3. So x over 3 equals, and I'm just going to set it equal to the scale factor because I already did 18 over 4, which is 9/2. So all I did was set up a proportion, because if these are similar polygons, then that means they're proportional in size. So I set up a proportion, and again I did x over 3 equals 18 over 4, but we already reduced that earlier, so I just put 9/2. So to solve, cross multiply and divide. So I have 2x equals 27. Divide that by 2, and that is 13.5. So x equals 13.5. Okay, now I need to do the same thing for y, and I need to erase this. So when I set up for y, now I'm looking at UT, so y plus 2, over its corresponding side, which is 5. And again, I can use the scale factor to set it equal, so that will be 9 over 2. So again, cross multiply, so that would be 45 equals, now when you have a number times y plus 2 or an expression, you have to distribute. So when I write this out, I'm going to write 2 times y plus 2, so that I know that I have to distribute my 2 to both terms inside. So I have 45 equals 2y plus 2, because I multiplied 2 times 2. And now I can solve for y. So I'm going to subtract 4 from both sides, so I get 41 equals 2y. Divide by 2, and y is 20.5. There we go. So make sure you just set up your proportion, and you can use your scale factor for one of those ratios. Okay, here's another example that I want to show you to help you out. It says quadrilateral ABCD is similar to quadrilateral EFGH below. Answer the following questions. Complete the following. If I'm looking at the measure of angle E, E is corresponding to A, and if these similar polygons are corresponding angles, those angles are congruent. So if angle A is 60, so is angle E. So this is 60 degrees. Okay, now we're looking for the measure of angle G. Well, we know it. It's right angle. So that is 90 degrees. The measure of angle B, B is corresponding to F. So if F is 100 degrees, so is B. So this is 100 degrees. And now we're left with H. H is corresponding to D, but we don't know D. But we can find it. There's two different ways you can find it. In a quadrilateral, all of the angles should add up to 360, and that's the way that I'm going to show you. So we know that all four of these angles should add up to 360 degrees. So we need to find one of the missing ones. And you can do this for either quadrilateral because they both have the same angle measures. So we take 60, 100, and 90, add those together, and we get 250 degrees. If we take that away from 360, that'll give us what's left for angles D and H. So that is 110 degrees. So if H is 110 degrees, so is D, and we just fill it in down here. H is 110 degrees. So we worked with our angles. Now we need to work with our sides, just like we did on the last example, on example 7. So first I need to find EH. EH is corresponding to AD. So I'm just going to call EH X because there's nothing written there. So I'm going to say X over 5, its corresponding side, equals, and I'm going to pick another pair of sides. I'll just pick 18 and 6 because those are the only two that have values. So I'll set that equal to 18 over 6. Now I'll cross multiply. 18 times 5 is 90. So 90 equals 6x. Divide by 6. X equals 15, which is EH. So we just found that side. Okay, we found X. Now we need to find BC, which is right here. If we look at the scale factor, we can do this without using a proportion. If we look earlier, DC is 6 and HG is 18. So to get from 6 to 18, you can multiply the 6 by 3, and that'll get you to 18. So that means our scale factor is 3. Again, with AD, 5, and then EH, what we just found, is 15. So if we multiply 5 by 3, that'll get you 15. So if we have 9 for FG, instead of multiplying it by 3, if we're going from big to small, we can take 9 and divide it by 3 and get 3 for BC. Same thing with EF. We can take EF, 21, and since we're looking at the big polygon first, take 21, divide it by 3, which is what, Bradley? 7. Good job. So AB is 7. But you can still set up your proportions like we did for X if you want to. But once you know the scale factor, it may be easier for you to just use that.